Okay, so let's move on to class. So last class we had discussed about what is Kubernetes, what is K8s, and right, what are the main components in Kubernetes, and what is the Kubernetes architecture we discussed. Can you see my screen?
Yes, sir.
Okay, so mostly Kubernetes is also orchestration engine. This is also open source platform for managing containerized applications. But here it is following master and worker node architecture. This is the main. So remaining concept same only. So the main what is the Docker Swarm? Alright, this is almost deprecated. Now most of the we are using instead of Docker Swarm, we are using Kubernetes. Same purpose here we are that architecture it is following manager and worker nodes. In Kubernetes we are following master and worker node. That's it. But concept is same only. But compared to Docker Swarm, so Kubernetes there is many advantages available, many features, extra features available. So that is the reason. So mostly we are using Kubernetes. And so these are the main components. So it is following master and worker node architecture. So at least so one worker node is needed. So one master, one worker node. And so last class we discussed, right? So what is API server and scheduler? These are the main components in master. And if we come to, we can create multiple worker nodes. At least we need one worker node. If you want to set up, right, Kubernetes, that is master and worker node architecture, at least one master and multiple worker nodes or multiple nodes. Both are same only. Worker node or node both are same. Okay. So these are the main components. Right, what is API server? And if you send any request, the first request go to API server. API server reads the request and that information it is stored into the etcd. Etcd act as like a db and it store the data in key and value format. Key and value format. And right, what is scheduler? Just learn if anyone asking, so what is API server? What is scheduler? Scheduler is nothing but keep on watch the pod and schedule these pods to worker nodes. So where is that? Last class we discussed. See, scheduler watches the pods and assign these pods to run on specific node host. Host is nothing but which node, which worker node you want to run this pod and all. And these are the controllers. There is many controllers available. So controller manager runs the controllers in background which run different tasks. There is many tasks. There is a node controller. So node controller means it is maintaining only worker nodes. All worker nodes. It is responsible for noticing and responding when nodes goes down. Whether if any worker node goes down. So it is who is handling? Node controller is handling. There is a replication controller. This is the how many number of parts. Okay. Next endpoint. Next replica set, deployment controller. So these all are the new terminology. Try to understand. And anyway, daily we are discussing same thing, right? We can easily understand. But as the time being, so just understand what is master, what is worker node. So So if you go to here, so this is a Kubernetes following master and worker node architecture. We can create multiple worker nodes. So that is your wish. How many you want, we can create. So how many you want, we can create. So it is following master and worker node. Interview mostly they are asking this one only. Can you explain Kubernetes architecture and can you explain what are the main components in Kubernetes? What are the main components in Kubernetes? Got it? So yesterday we discussed a few components. This is the master. This is the master. This is the worker node one. Like this we can create worker node one. Worker node one. How many you want we can create. But here at least we are maintaining one master, one worker node. Worker node two. So now if you go here, now if you go here, so what are those? So here mostly there is API server, API server. So if you send any request, first we will receive API server. Next, etcd, next scheduler, next controller. So these are the main. Now if we send any request, so if we send any request, first the request come to from, so we can send whether UIA or whether we can send request GUI. We can run commands two ways, right? So one is GUI, that is UI, user interface, or GUI, graphical user interface, or we can use also command CLI, command line interface, or we can use CLI, command line. Okay, if we send any request and the first request received by API server, API server knows everything. API server knows everything, and so whichever we want, so that information and all it is stored into the etcd. And what is scheduler? Scheduler keep on watches the pod, and if you go here, we know, right? So here we can see pods, here we can see pods and docker and kubelet. Today we'll see what is kubelet, kube proxy, kube proxy. So these are the main components in worker node. These are the main components in worker node. Okay. So these are the main components in worker node. I hope you got it right. So anyone, any doubt, guys? So these are the main components in worker node. So in every worker node we can see these are the four components. Okay. So like this, if you need one more worker node, if you want to, we can add it. So that worker node also same components. Parts we can install Docker, kubelet, kube proxy. So that is based on requirement. We can add many worker nodes. Okay. Simply it is following master and worker node architecture. And if you come to master, these are the main components, and if you come to worker node, so these are the main. Already know some idea. So what is API server, what is etcd, what is scheduler, controller? There is a node controller, replica set controller, replication controller, next endpoint controller, job controller, deployment controller, demand set controller. There is many controller comes under controller. And so every controller it is taking for specific task, specific part. Okay. So this already last class we discussed, right? See here, node controller, node only handling worker nodes. Whether any worker node is working, is there is some problem or it goes down, that and all identified by the node controller. And so see here, there is jobs and all controlled by job controller, and parts and all controlled by replication controllers or replica sets. And endpoint, if you want to join the service and part together. And these are the deployment. This is the declarative updates for parts and replica set. How many parts you want, and what is the health status of your parts. So that and all taking care. And this is the demand sets. Ensure all nodes run one copy of specific parts. So this is, just remember, these are the controllers: node controller, replication controller, endpoint. So many controllers. Now if we come to worker nodes, so now if we come to worker nodes, these are the main components, right? So here, anyone, any doubt, guys? Master, I hope you got some idea, right? So what each components, what is the exact role, how it will work? Hello, clear? Now come to here, we'll see this and all. If you understand this entire architecture, these all components remaining very simple only. What is happening, and just we are executing only commands, that's it. Now come to here. So now this is the, you have some idea. Now come to, so worker nodes. See here, worker nodes are the nodes where the application actually running in the Kubernetes cluster. Now, so here, right, this is a master and this is a worker nodes. If I deploy any application, anyone guess it, application running in master or worker nodes?
worker nodes.
Only worker nodes only. Only worker nodes. Don't confuse here. See here, worker nodes are the nodes where the application actually running. So if you deploy any application, for example, I deployed one Java application and any .NET application, anything. So, where it is running, only worker nodes. So this is a master. Master is nothing but it is controlling worker nodes. It is the controlling, managing all worker nodes. That's it. Very simple. Now see here, it also And next, these each worker nodes are controlled by the master node using the kubelet process. How this master handling your worker nodes with the help of kubelet only, with the help of kubelet process. So that is here we know, right? There is a kubelet also is there, and kubelet handling, that is containers and network everything. And so master is handling worker nodes, and how these are nodes are controlled by the master and node using processor. So there is a kubelet. We'll see what is kubelet and all. Next, container platform must running on the each worker nodes and it work together with the so kubelet to run on the containers. These are the same, and we can also use other container platform like Core OS, Racket. mm, there is many, right? So these are the communication purpose. We can install it whatever you want. But anyway, mostly here we are using kubectl. Now, what is see here? Kubelet. So, most of the people they are asking what is kubelet. Kubelet is nothing but this is the primary node agent. Right? Agent, LIC agent. If you take any office, there is some agents available, right? What they will do? Same. So, that is what they will do? Same. See, kubelet is the primary node agent run on the each nodes. So, now here there is a worker node. So, here there is a one kubelet, and this is the one worker node. Here also it is running one kubelet. Suppose if we add one more worker node, here also the kubelet available, here also the kubelet available. Got it? So every worker node there is one kubelet. The kubelet is nothing but this is the primary node agent. Remember, this is the primary node agent. I hope you understand what is agent. And each node and reads the container manifest file. See here. So what it will do? It will read the container manifest file, and which ensures that containers are running and healthy or not. So what is the primary role of kubelet means? This is the primary node agent, and every worker node it is running one kubelet. What it will do? It is keep on monitoring. It keep on checking. It makes sure that containers are running or healthy or not. So here we are going to create multiple containers. All containers healthy or not. All containers running or not. So who will taking care? Kubelet only it will take care. So it makes sure that containers are running in the pod. So whether the container running in the pod or not. So the kubelet does not manage containers which were not created by the Kubernetes. So kubelet it won't take any care which are not created by Kubernetes. Suppose some parts if you are not created, if you are not created by anything, so that and all it won't take care anything. It won't take care anything. So that is the main role of kubelet. Kubelet is nothing but this is the primary node agent. It is running on each worker nodes. Each worker nodes. And what is the main purpose? It is checking whether containers are running or healthy or not. Got it? And it is make sure that containers are running in the pod. If we have any problems, if we have any issues, so that and all taking care by kubelet only. Suppose if you go LIC, if you need any one policy, so there is a mediator, right? That is no agent, LIC agents. So if you ask agent, so they will give entire information, they will provide. So what are the features, what is the advantage, disadvantages, they will give some idea, right? So who will take care here? Kubelet only. So kubelet is the primary node agent, and it is mostly checking, it is checking that containers are running are healthy, or so exactly the containers are running inside the pod or not. Okay, so that and all taking care by kubelet. So this is the one component. Kube proxy, right? So Docker network. So in Docker network, right? Same concept here, kube proxy. I hope everyone know Docker network. What is the purpose? Why you go for Docker network and all? Same here, kube proxy. This is the proxy. So this is total related to same only like Docker network. If you understand Docker network, simply here kube proxy. So kube proxy is enable the Kubernetes service. This is the abstraction by maintaining network rules. These are the network rules on the host and performing connection forwarding between your pods. So simply if you want to understand, this is the network rules. Kube proxy is nothing but network rules on the every host and performing. connection forwarding, how these parts connecting, and which worker node you want to connect. So this and all everything taken care by queue proxy only. Queue proxy maintains network rules on the nodes, every node. Now if you see here, every worker node there is a queue proxy, and this queue proxy main purpose is network rules. These network rules allow network communication your parts. So what is the purpose? So these network rules, so here we have one pod, here we have parts, here we have pod, and how these pod are communicate each other. And here also I am going to create multiple parts. So how these containers communicate each other. So this and all taking care by queue proxy only. See here, queue proxy maintains network rules on every worker node, and these network rules allow network communication to your parts from inside outside of your cluster. I hope you got it right. So this is the main purpose. Simply understand one or two lines. That's it. Remaining. So now we hear many multiple parts. Here also parts. How these parts communicate with this part. This part is communicating this with the help of cube proxy only, with the help of cube proxy only. So with the help of cube proxy, these parts communicate with these worker nodes, and these parts communicate with these parts, and like this. If you want to connect with, there is a network rule, and a network rule maintain so all nodes, and these network rules allow network communication to your pod from inside or outside your cluster. Suppose if you this is the one cluster, suppose if you have another cluster, so from that cluster, I want to communicate with this parts. That case also possible. So that case, this is the one cluster. Just assume this is the Java project related Java projects and all deploying in this cluster only. Cluster is nothing but a group of servers. Cluster is nothing but group of servers. Don't confuse. Multiple servers. Here cluster means group of servers. Suppose we have one more cluster. So there is a one pod. That pod communicate with this cluster. So that case we need to configure queue proxy only. So with the help of queue proxy only, so these pods are communicate one cluster one inside or outside the cluster. And it helps to have the network proxy and load balancer, right, everything it is handling. And service is just logical concept. The real work is being done by the queue proxy only. So here also there is one service object is there. We'll see later what is service object and all, and how it will work, and it redirect request from the cluster IP. And so here also there is some right service object available, and so that service we have four types is there, and with the help of these all are communicate each other. Anyway, we'll see what is cluster IP and node port and load balancer and external name. There is four type of services available. We'll see later how it will work. And every pod has one IP, unique IP address, and with the help of all are communicate each other. Okay. So now kubelet is, this is the primary node agent run on the each worker node, and it reads the container manifest file, and also it is checking whether containers are running or not, healthy or not. What is kube proxy? Kube proxy is the primary network rules on every worker node, and these network rules allow network communication to your pods inside or outside your cluster, inside or your outside your cluster. Just remember one line, that's it. So you understand what is a cube proxy main, and this is the containers. So every right, every node, this is the worker node, must have containers runtime, and in such a docker, and rkt or another containers. So here mostly we are using so docker, here mostly we are using docker, right? So with the help of docker only, we are going to create containers, and all containers running so with the help of this only. Now see here, we can process instruction from the master server to run the container. So with the help of based on master, the containers that parts are running with the help of Docker only we are creating. Docker and all, so I hope everyone know. So what is Docker and how it will work? Now there is a main is there. There is a pod. There main. There is one more, right? Pod. This is very important. Interview also many people asking what is pod. So this is the one of the main object in Kubernetes. See here, Kubernetes objects, there is a pod. So as of now we discuss, right, pod, Docker, right, what is kubelet, you have some idea. What is kube proxy, some idea. And Docker and all, what is the purpose of Docker and how it will work. Now there is one more main object, Kubernetes object, pods. Now if you come to pods, try to understand, pod always run on the node. Pod always run on master node or worker node. Based on this,
Worker nodes.
only worker node. So inside pod, so there is two types of pod, single container pod or multi container pod. So see here, always these pods are running worker node only, not in master is like manager. Master is like manager, it is handling our worker nodes only, our cluster only. Cluster is nothing but group of servers. And so with the help of these, with the help of these components, master communicate with master is controlling our worker nodes. Now there is one more object, pod always run on the worker node only, that is nothing but worker node. Okay, now the pod is the smallest building block or basic unit of scheduling your Kubernetes. So what is pod interview, also many people they are asking what is pod. So if anyone asking, just remember, just pod. So pod is nothing but a Kubernetes pod is the collection of one or more Linux containers, that is right, anything Linux, or it is the smallest unit of Kubernetes application, and inside this pod only container is running. See here, any given pod can be composed of multiple or tightly coupling containers, and we can create multiple parts. We can create multiple parts. This is the official document. If you want to, this is official document, Kubernetes, see, kubernetes.io and docs. This is the pod is the smallest deployment unit of computing that you can create and manage in Kubernetes. So this is the one deployment unit. This is the one smallest deployment. Pod is the smallest runtime instance or smallest deployment unit of computing that you can create and manage your Kubernetes. Pod is group of one or more containers. So maybe single container pod or multi-container pod. So pod, inside the pod, if you want to, we can create one container, or if you want to, we can create multiple containers also. See here, a pod is the group of one or more containers. So now got it right. So this is a pod. Inside this pod, maybe at least one container, or else we can create more than one container also. Now try to understand, all containers running where? All containers are running inside pods or kubelet or kube proxy. All containers running inside the, ఎక్కడ ఉన్నాయి containers అన్ని, inside the all containers are running inside pod only, inside the pod. There is a single container or multi container pod also. If you want to, we can, at least we need one container. In suppose we have one pod, so every pod has one container. If you want to, we can create, we can add more containers in the same pod also. So that is the multi container pod. See here, pod run single container and also multi container pod. So if you want to, we can single, see, only one container per pod, this is nothing but a single container. Pods that run on single container. If we have only one container, that is the single container pod. Suppose if quad has multiple containers, that is the multiple containers. So a pod can encapsulate an application composed of multiple containers. So multiple containers, if you want to, we can create, that is based on your requirement, whatever you want we can create. Now got it guys? Anyone, any doubt here? And so every pod has unique IP address also. Where is that? Now see here. So this is the smallest building block. Whatever you want, what you understand, just remember only one line answer. Most of the people they are asking what is pod in Kubernetes. So pods are the smallest deployable unit of computing that you can create and manage your Kubernetes. And so every pod has some properties. See here, in Kubernetes cluster, pod represents running process. Pod represents running process. Running means inside pod container is running. Inside pod you can have one or more containers. So inside pod, so every pod, so if you want to, we can create minimum at least one container, and maximum that is based on requirement we can create. And these containers all share a unique network IP, storage, network, and any other specified application to the pod. So for example, this is a pod, right? So this pod has some CPU, this pod has a network, this pod has some space. So this all resource are used by containers only. Now got it, don't confuse here. This is a pod. So this pod has some unique, see unique network IP. Every pod has one unique network IP and also some storage and also some network, and these all resources used by containers. So inside the pod, containers are running. Now these resources and all this application is specified by the containers only. Don't confuse here. So every pod has one unique IP network IP and also some storage, some network rules, and any if we have any other resources also. These all resources used by containers. Inside pod there is multiple containers or single container. So that container only it is uses all these resources. Pod is a group of one or more containers which will be running on same node, some node, and pods abstract network and storage away from the underlying containers. And so this is the each pod has unique IP address. This is very, very important. So every pod has one IP address. Every pod has one IP address, and within the cluster, and any data saved inside the pod will disappearing without the persisting. This is the storage concept. We'll see later. You know, right? Docker, there is a volume concept, right? In same way, if we come to Kubernetes, this is the this is the this is the this is the volume concept. This is the persistent storage. This is simply we are calling storage concept. Same in Docker we are using volume, and so if we come to Kubernetes we are calling storage. Here there is some storage types available: PV, PVC, persistent volume, claim. So there is types is there. We'll see later. Don't confuse here. Okay. Now, so if anyone is asking, mostly they are asking this one: what is pod? What is pod? At least you remember one or two lines. What is the pod? So a pod always run on the node. Pod always pods. Mostly all pods are running worker nodes only, not in master. If it is mini cube bundle, that case here working. But generally we are following master and worker node architecture, and every worker node has pod, and inside pod containers are running, whether that is single container or multiple containers, and each pod has one unique IP address, and each pod has some network rules, each pod has some storage. These resources used by containers. Inside the pod, containers running, containers only it is using. Got it? Anyone, any doubt here? Clear, guys?
Yes, sir.
Yeah.
Okay, so just remember one or two what you understand based on this. So each pod has unique IP address. This whichever containers running inside the pod, so that all containers using these existing resources, network IP, storage, network. If any other specification, also any specification also applied in the pod, that containers only using. So and every pod has unique IP address within the cluster. So anyway, we'll see practically how it will work. And so the pod is the smallest building block. What you understand, just remember one line, whether only this definition or if you Google it, will get many definitions, right? See here, pods are the smallest deployable unit of computing that you can create and manage in the class Kubernetes. And every pod has unique IP address, and there is some IP address, some resources, network. Inside this inside pods there is containers, that containers are using, that is single pod container or multiple containers also. So basically mostly we are going to deploy single container means, so if you're running only one container inside the pod, that is single container. Suppose if you create multiple containers, that is the multiple containers pod. So that, and also here we can see here, and see here pod. So that is the one container for pod and multi container per pod. So we are going to create multiple containers, and this is pod model types. Okay. Now, so this is a pod life cycle. We'll see how it will work. Pod life cycle means, so if you see, make a pod request to the API server. For example, I need a one pod. I need one pod. So the request go to whom, guys? First, based on this diagram. For example, I am the UI level or I am CLI level. I need to create one pod. So first the request go to whom? If I send any query, if we run any command, so that first that request go to whom? Who will receive that request?
Master.
Master only. Master, inside master, which component? There is four components, right? The request and all received by whom? Who? API server or DTC or scheduler or controller?
Controller.
Control.
Controller. నిన్నంతా విన్నాం కదా. API server act as like front desk.
Okay.
సో మన ఏ కమాండ్ ఎగ్జిక్యూట్ చేసినా ఏ కమాండ్ రన్ చేసినా ఇఫ్ యూ నీడ్ ఎనీథింగ్ ఫస్ట్ ద రిక్వెస్ట్ గో టు హూమ్? ఏపీఐ సర్వర్ ఓన్లీ. మనం ఏ క్వరీని ఎగ్జిక్యూట్ చేసినా సో ద రిక్వెస్ట్ ఫస్ట్ గో టు ఏపీఐ సర్వర్ ఓన్లీ. ఏపీఐ సర్వర్ స్టోర్ దట్ ఇన్ఫర్మేషన్ ఈటీసీడి, కీ అండ్ వాల్యూ ఫార్మేట్. నువ్వు పంపించిన డేటా మొత్తాన్ని ఎక్కడ స్టోర్ చేస్తుంది? ఈటీసీడీలో స్టోర్ చేస్తుంది, key and value format. With the help of this information, scheduler controller handle your worker nodes. That's it, very simple. Now same story here also, don't confuse. If we make a pod request to API server, see here, for example I need one pod. ఇప్పుడు నేను ఒక పాడ్ క్రియేట్ చేయాలి. నీకు పాడ్స్ క్రియేట్ చేయాలంటే ఒక కమాండ్ ఎగ్జిక్యూట్ చేస్తారు కదా. ఈవెన్ డాకర్ ఆల్సో మనం ఒక కంటైనర్ని క్రియేట్ చేయాలనుకో, డాకర్ కంటైనర్, వీఆర్ రన్నింగ్ సమ్ ఎగ్జిక్యూట్ వన్ కమాండ్, CLI కమాండ్, ఎనీథింగ్. దట్ ఈస్ ద క్లయింట్, రైట్? డాకర్ క్లయింట్. డాకర్ క్లయింట్ సెండ్ రిక్వెస్ట్. దట్ రిక్వెస్ట్ ఎవరికి వెళ్తుంది? డాకర్ డీమాన్కి వెళ్తుంది. అప్ టు డాకర్, రైట్? ద రిక్వెస్ట్ గో టు డాకర్ డీమాన్. డాకర్ డీమాన్ knows everything. Same way here, who everything knows, who API server knows everything. ఏపీఐ సర్వర్కి అన్నీ తెలుసు, లైక్ ఫ్రంట్ డెస్క్ ఎక్కడెక్కడ ఏ ఫ్లోర్ ఉంది. మనకి ఆఫీస్కి వెళ్తే ఫస్ట్ మనం ఎక్కడికి వెళ్తాం? ఫ్రంట్ డెస్క్కి వెళ్తాం కదా, ఎవరు మీట్ అవ్వాలి, మనకి ఏం కావాలి. సేమ్ హియర్ ఆల్సో, హియర్ దట్ ఈస్ లైక్ ఏపీఐ సర్వర్. ఏపీఐ సర్వర్ నోస్ ఎవ్రీథింగ్. బేస్డ్ ఆన్ యువర్ రిక్వెస్ట్, నౌ యువర్ రిక్వెస్ట్ గో టు డిస్ట్రిబ్యూట్ టు వర్కర్ నోడ్స్. సేమ్ స్టోరీ, సీ హియర్. ఇఫ్ ఫర్ ఎగ్జాంపుల్ ఇఫ్ యూ వాంట్ టు మేక్ ఎనీ పాడ్, the request go to API server using a local pod definition file. Here we are going to write some files. That API server saves that information into the etcd. So for example, we send one request, I need to create one pod. So I executed one query. That query first goes to API server. API server knows, okay, this guy requested he want to create one new pod. So and we send one query, right? That information it is stored into the etcd. Now see here, same, that API server saves that information for the pod in the etcd. Now scheduler, right? What is scheduler? Scheduler watches the pods. ఇప్పుడే డిస్కస్ చేసినాము. వాట్ ఈస్ స్కెడ్యూలర్? స్కెడ్యూలర్ ఆల్వేస్ వాచెస్ ద పాడ్ ఓన్లీ. నౌ సీ హియర్, స్కెడ్యూలర్ వాచెస్ ద పాడ్స్ and assign the pods to run on the which worker, which host mission, which worker node. As of now what we discussed, that and all we are highlighting here, that's it, nothing. This is the pod life cycle. Now see here, scheduler finds the unscheduled pods and schedule to the worker node, that's it. So scheduler always watching the pods. If any pod is not scheduled means no work. For example, I created one pod and that pod we need to run any worker node, right? If you are sitting ideally, your manager will give task. Hey, go and search this and all, or go and do this one, and go and check whether this is not running properly. They are assigning some task. Same way, scheduler finds the unscheduled parts. Scheduler finds the unscheduled parts and assign to particular worker node. Any worker node, maybe this worker node, or this worker node, or this worker node. Leave it. That different concept we'll see later. Now got it? So scheduler ఏం చేస్తుంది? It finds the unscheduled parts. Which part is not scheduled to any. See, the scheduler finds the unscheduled part and schedule it to the worker node. And kubelet, right? What is kubelet? Kubelet is nothing but this is primary node agent running on the each worker node. See the pod scheduled and fire of the docker a. So there is a one pod assigned to you, and so inform the kubelet. Right, this is the primary node agent. So what it will do now, it will find this particular pod and it will fire the Docker or execute that commands and all. And Docker run the container. Docker what will do? It will run the containers and the entire life cycle state of the pod store into the etcd. This entire information it is there with it maintaining into the etcd only. This is the pod life cycle. Anyone any doubt here? Same. ఇప్పటివరకు మనం ఏదో డిస్కస్ చేసామో సేమ్ పాయింట్స్ వీఆర్ హైలైటింగ్ హియర్ హౌ ఇట్ విల్ వర్క్. Okay, now just understand, if you send any request, the first request go to API server only, not scheduler. API server knows everything. API server write that information etcd. Based on this information, scheduler work controller is working on that. Clear? Anyone any doubt still? Hello? Yes or no? Clear?
Yes, sir.
Okay, so this is very very important, just try to understand. Okay, so read once or twice, we can easily understand. If you understand this entire work, if you understand this entire architecture, there is nothing remaining and all, just we are executing one command. If you know Docker very well, we can easily understand this one also. In Docker lo మనం ఏం చేస్తాం? Docker client to Docker daemon. If you Docker client is nothing but end user. If you execute any command, Docker run, Docker full, Docker search. So whatever you are executing, that command goes to Docker daemon only. Docker daemon knows everything. Docker daemon knows everything based on your request, and we are getting output. We are getting output, but there is only two components, right? Here there is many components, and each components there is specific rule, specific it is handling specific task and all. So that is the reason we need to understand this and all. I hope you got some idea, right, how it will work. Still anyone any doubt? So what is this, what is how it will work? And pod concept, pod is right, this is the, it won't reschedule it to the new pod once it is die. See here, for example, pod is running. Inside pod, containers. Here pod means blindly remember. Inside pod, containers are running. Inside pod, containers are running. Inside pod, containers are running. You should not directly create use pod for deployment. Kubernetes have control. There is a replica set and deployment demand set keep, and there is some right objects available. Now anyway, we'll see that and all. I hope you got some idea, right? So anyone still any doubt here? So what is API server and what is etcd, scheduler, controller, what is pod and what is Docker, Docker and all already we know, what is kubelet, what is kube proxy. This is total handled by network rules, and kubelet is the primary node agent, and it is checking the containers whether containers are healthy or not. So everything it is checking. And Docker already know what is pod. Pod is nothing but this is the smallest deployment, smallest deployment. So smallest deployable unit of computing that you can create and manage in Kubernetes. So our Kubernetes is the smallest runtime instance, and so inside pod containers are running. Inside pod only containers are running. Remember this point. This is the basic point. So all containers running inside pod only, inside pod only. In Docker directly we are searching, right? So but in Kubernetes all containers are running inside pod only. So this pod may be single container or multi containers. Only one container is running, that is single container. Single container pod. Here we see, right? So that is a single container pod, and multiple containers are running, that is multi container pod. This is the, see here, one container for pod. So this model is the mostly popular. Pod is the swapped and single container, and so multi container means this is also in this model. Pod can hold multiple co-located containers. So if it is running multiple containers, this is a multi-container pod, or also sidecar container. Sidecar. So remember, some one or two people they asked what is sidecar. Sidecar is nothing but multi-container pod. Don't confuse here. Single container already know, one container for pod. Multi container pod means, or sidecar means, multiple containers running in pod. Multiple containers are running in pod. Got it? What, Hemant? Clear? Anyone any doubt here? Just remember, sidecar container or multi container pod both are same only. So that is based on our requirement. We can create single container, or if you want, we can create multiple containers also. Now you got some idea, right? Now you got some idea what is these components, how it will work. Now if you come to here, come to here, there are few objects available here. Kubernetes basic objects. We are going to discuss that one. So if you go to here, so in Kubernetes there is many resources available, many objects. Now here somewhere we can see what is this, not here. So try to understand. This is very simple only, but initially these are the new terminals, right? We need to try to understand. See here, there is a Kubernetes objects. So if you come to, there is many features available, right, in Kubernetes. Already you know there is lot of features available. We will see one by one. So these are the basic Kubernetes objects. See here, Kubernetes objects are the per persistent entities in the Kubernetes system. So these are the objects. See here, there is a pod, replication controller, replica set, daemon set, deployment object, service object, volume, jobs. Not only this, config map, secrets, config map, secrets. There is many objects available in Kubernetes. So with the help of these only, we are going to create, we are going to manage our entire, right, Kubernetes pods. We are going to create, we are assigning, creating pods and assigning storage. As of now, right, volume network and all Docker side, same concept we are going to update here, we are going to implement, but these are the new terminology. So pod, replication controller, replica set, daemon set, deployment object, service object, volume object, job object. With the help of, we are going to see here, Kubernetes object is the record of intent. So once you create the object, the Kubernetes system will constantly work to ensure that objects are existing. So once you created any pod, once you created anything, so keep on it is maintaining always whether this pod is working or not. So one controller is there, and scheduler, what is the purpose where we want to run, it will take care scheduler part, controller, so that and all. So these are the objects. This is the new terminology. Try to understand pod, replication controller, replica set, daemon set, daemon object, service object, volume and all. So these are the purpose. So to work with Kubernetes objects, whether we can create, whether we can modify, whether we can delete, whatever you want. And one more thing here, if you want to create any object, Kubernetes object, there is two ways we can follow. So directly we can use ada commands, or we can use some manifest file also. See here. So whether we can execute, where is this? You can create, if you want to create any pod, or if you want to modify the existing pod, or if you want to delete the existing pod, we need to use the Kubernetes API. So application program interface. So already this is available. With the help of, we are going to execute. When you use the kubectl command, this is the command line interface. So this is the CLI. With the help of CLI only, we are going to execute all commands. In Docker, how we are executing? Same concept here also. For example, in Docker, mostly we are using Docker, right? Now, if you go here, so for example, right, so Docker run command or Docker search command. Docker search, we are going image name, right? Image name. So this is the everything we are running CLI only. And same way, so here we are going to install, so we are going to install one kubectl command, command line interface. This is the kubectl. This is the one, right, so one client tool we need to install, and with the help of all commands we are running. So kubectl get parts means it will display only parts. If you use a kubectl get parts, it will display only parts. If you want to see only deployment, if you want to see only, right, replica set. So this is the command. Mostly we are using like this, kubectl get, kubectl rs, replica set. and kubectl get rc replication controller. So like these are the commands. Now, so I will show you how to set up and all. And before executing, we need to set up Kubernetes, right? So there is many ways we can do it. Whether we can use, I hope already you know, AWS, right? Cloud. So in AWS also there is a one feature available, EKS, EKS. But we need to pay some amount based on hours. They will charge something, or we can use Minikube, or we can use a Minikube. We can use Minikube, or we can use a Docker desktop, Docker desktop desktop. And so there is many ways we can set up, there is many ways we can set up so Kubernetes. So now if you use EKS and all, so based on hours they will charge something, but anyway mostly we can use Minikube and so Docker desktop. In our local I am going to set up, and no need to pay anything, everything it is running our local only, everything it is running our local only. Later we'll see EKS. This is the one of the topmost service available in cloud. And so we can set up entire Kubernetes. But so based on your usage we need to pay some amount. But anyway, initial I'm going to set up Docker desktop only. Initial I'm going to set up Docker desktop, everything working in my machine only. And so no need to pay anything. Whenever if you want we can work. And some of the features not working, that and all we'll see EKS. That and all I will show you AWS. I will show you AWS. Okay, so this is the one simple, we need to install one software, Docker desktop. If you go on Google, if you want to set up how to set up so Docker desktop, you, I hope everyone using Windows only, right? Anyone using Linux and all? Hello, all are using Windows operating system only, right? Laptop.
Windows.
Windows. So Windows means if you go browser, just download the Docker desktop. Download, download, Docker, download Docker Docker desktop. So see here, if you go download, if you click on Docker desktop is the collaborative containerized software for developers. If you want to create pods or if you want to deploy pods, whatever you want, this is the, if you click on this and see here, containerization software for developers under teams. So create a account and download Windows. Now see here, so this is for one is Mac, one is Linux, and so download for Windows. If we click on this, if we click on this, download directly, it will download one file. See here, this is the exe file, this is the exe file, this is the Docker desktop installation. Okay, this is the Docker desktop, this is the Docker desktop installer file, exe file. Okay, so this is here, it will show only 470 MB. If you install Docker desktop, nearly it will occupy 15 GB, nearly it will occupy 15 GB. Before installing Docker desktop, make sure that this space is available or not. Anyway, next class I will show you how to install Docker desktop in our Windows machine, and how to play with Kubernetes. Just I am showing. So this is the we can if anyone already, if you have idea, directly download Docker desktop, try to install. Next step and all I will show you. Now see here, in my machine already installed. If we click on this, it will come like this. If we click on Docker desktop, already installed in my machine. Next class I will show you. And now see here, it will come like this. This is the UI, this is the dashboard, this is the front page. See here, it will come starting the Docker engine. First, Docker engine is the underlying technology and that runs all containers. Once you install Docker desktop, desktop, it will come. But before that, there is few more steps also we need to configure. I will show you next class. But this is a Windows, this is a Windows. Okay, no need to pay anything, no need to go anything. See here, if you go here, if you go here, settings option, right side top corner, there is a one option is there, gear symbol. If you click on settings symbol, and so there is a, see, general resources, Docker engine, Kubernetes software update, there is few things. Already this is the Docker engine is running, so no need to worry. And click on Kubernetes, see here, here automatically Kubernetes, so it is running. So which version we are using, guys, here? Kubernetes version. Last class we discussed, right? Latest version is 1.3029, right? And currently I am using which version? If anyone is asking, so which Kubernetes version you are using, what we need to say? Don't tell 30, 29 and all. Just say lower version only. So 1.25 or 1.27 like that you can say. Got it, Hemant? అర్థమవుతుందా? సో కరెంట్లీ
Yes,
విచ్
sir.
దిస్ ఈస్ ద క్యూబర్నెట్ వర్షన్ విచ్ వర్షన్ వీఆర్ యూజింగ్ v1.25 we are using 25. The latest version is 30. Last class we seen, right? 30 or 1.29 also, that are the latest. But currently I am using the Kubernetes version 1.25, 1 point version 1.25. Okay, now see here, if you go down, if you go down top, left side bottom, there is two tabs available. See here, this is the Docker and this is the Kubernetes. So both it will come green, both will come, see, running. If you see initial, it is not running. So now it is running. If both are running means now directly we can connect with now play with Docker as well as Kubernetes. Docker as well as Kubernetes. Now see here, go to somewhere. Once this is setup is ready, go to anywhere, that is your wish. Go to anywhere, create one folder. Now if you go here and right click, open whatever you want, or directly go cmd. Okay, prompt. It will come command prompt. So now see here, here mostly we are using so kubectl get whatever you want, so we can use and all. Now see here, there is two parts are running. These are the kubectl. So this is the kubectl. We need to set up this and all. Next class I will show you how to set up and all. So you know, right, how we are searching Docker and all. See here, so how we are searching, same way. See, these are the Docker images, and these are the Docker images. If you want Docker, anyway it is running by default, Docker running and Kubernetes also running, and these are the commands. Now next class onwards we are play with the some of the Kubernetes commands. Kubectl get svc, this is the service object. Kubectl get svc, these are the basic commands only. And kubectl get pods, and if you want to see kubectl get RC, replication controller, and so get kubectl get RS, replica set, you know, right? And so kubectl, these are the some of basic objects. Shortcut I am using here, we discuss, right, where we discussed here what is pod. And this is the RC means replication controller, RS means replica set, DS means so demand set, and deployment object, and service object SVC, and these are the shortcut I executed here. Anyway, next class I will show you how to set up Docker desktop in our local machine, and how to play with your our Kubernetes so parts and all. If anyone already, if you have idea, try to download Docker desktop and try to install it. Next class I will show you step by step and we can easily understand. So few people new to Kubernetes, right? So they can't understand, they cannot. We need to do some steps. Even Google it, they are giving a step by step entire process. We can follow same steps also. That is your wish. Okay? Clear, guys? Anyone any doubt? So here Docker Kubernetes architecture and all. So mostly focus on Kubernetes architecture and what are the main components, and each component what is the role, how it will work. Clear? Hemant, clear? You can.
Yes, sir.
Okay. So next class I will show you setup, and as well as we'll play with some of Kubernetes commands as well.